Hello, and welcome to what is going to be one of my first of hopefully many videos that I'm going to post up about some of the math that we've been learning in class. This one has been made for my 7th grade classes. We've just started to push what we've learned about equivalent ratios, and some of the terminology that's going to be popular in the area that we're going into is direct variation, or identifying if we have direct proportions. And what we're doing in essence is we're taking what we've learned about equivalent ratios, and we're now pushing that into a sort of graphing format. And so if you're looking for this in kind of some of the odd spaces online, they call it direct variation. Or in essence, we're just showing, is a pair of ratios, are they equivalent? We're doing so graphically. Alright, and so first off, let's go ahead and draw ourselves a grid. Alright. That's what we're using, and this is always going to take place on a section of a graph kind of known as quadrant 1, for those of you that are familiar with graphs, or in essence, it just means that we're always moving in a positive direction when we think of our horizontal or x-axis, and in a vertical when we're thinking of our y-axis. I realize some of that terminology might be more familiar with our parents than with our students, but for now, we'll think of it as, if we're going along left to right, only goes just in that way, from left to right. We're going from the origin, which is right there. So we're going to go from left to right, and then we're also going to go from bottom to top when we're counting. Alright? So let's compare a couple of ratios, and let's compare first one that we maybe know is equivalent. So let's try a nice simple one like 1/2. And we know that's going to be equal to 3/6. Alright? Now we know that algebraically, and the way that we know that is we can think of our step here we've done in the past. We multiply by 3, and we'll multiply by 3 along the bottom. So 1 times 3 is 3, 2 times 3 is going to give us 6, so we know that, but now we're going to move on to showing it on a graph, and possibly looking at what are all the other ones before we even try to calculate. What can we already just say about other points? Alright, and for this one, let's say that, let's say up top we have a unit of, boys to whole students. We'll say that exactly half the class are boys, the other half are girls, and so 1 in every 2 students will be a boy. Alright? And for that, let's go ahead and just say that we'll make this one boys. And this will be total students over here. Okay? Alright, so if I have a small group of 6 students that's representing our class, I should expect there to be 3 boys, because each set for every 2, I usually get 1. That's what our ratio is saying here. So let's see if that holds up on our graph here. So I go, first I count my boys, so I have 1 boy, and I find that in a 2-person group. So once I'm over here at 1, I'll go up 2 points, 1, 2. And I will make a point. Now suppose then that I want to look at, I have 3 boys in my group. So I go over 1, 2, 3. And then I try to go up 6. 1, 2, 3, 4, 5, 6. Alright. And I'll make a point right about there. Alrighty. And I'll grab myself a sheet of paper or a ruler. I realize the ruler is probably the more common tool, but just want to show you, if you don't have rulers at home, you can always just use edge of a paper. Alright? Okay. Now notice here, all of our points line up. We have our origin, our point 1/2, and our point at 3/6. Alright? And if I was to even try and go up, alright, at the point where we have 4, then if I go over, I pretty much arrive right over at 8. So that can even tell us other proportional relationships that we have, and basically give us other equivalent fractions. So we can also see that 4 over 8, that's going to be equivalent to 1/2. So now we can just start reading them all off of the graph here. So it becomes fairly helpful. We can also use this to determine when we have cases that aren't equivalent. Let's try one more real fast. Okay, so we'll draw ourselves a grid. Okay, put a couple of marks there. Okay, and let's say that we have a parking lot, and we have either cars or trucks are parking in said lot. And we'll say that we have 2 cars, and then we'll say that we had 3 other trucks parking there, so 5 vehicles. Alright, hopefully I spelled that right. Keep in mind, I'm not the best speller. I'd like to think I got that right, though. Alrighty, and then supposing on another night in our parking lot we have 4 cars to a total of 6 vehicles. Okay, so let's go ahead and we'll keep up with our trend. The units that were on top we'll put along our horizontal axis, and up here along the one that goes up and down, our vertical, we'll say that that will be our vehicles. Okay, now with this in mind, I'd like students who are seeing this at home, who are feeling confident, go ahead and pause the video at this time and see if you can work this problem out on your own. Alright, welcome back. So, let's see how we did. First off, we have 2 cars. Go over 2. And then we go up 5 along our vehicles. So we go 1, 2, 3, 4, 5. Alright, and that gives us 1 point. And now, we'll go over to the point where we have 4 cars. So I'll go over 1, 2, 3, 4. And then I'm going to go up 6 vehicles. So I'll go up 1, 2, 3, 4, 5, and 6. Right about there. Now keep in mind these are rough sketches. Most of our problems that we get in the book, they'll actually provide us a nice set of grid lines. But for now, this one will show us pretty nicely what happens. Okay, so if I connect a nice line here, alright, we'll notice that the line is straight, but unlike our first case, up top, which went through the origin, this one doesn't. Alright, that's a point that doesn't come up. So that's going to actually tell us then that what we have here is a pair of ratios that aren't equivalent. We don't have a direct proportion here. Because if we were to actually connect the origin to our closest point, we see that's a very non-straight line. Alright, so with this information we can say that 2 over 5, or 2 cars to 5 vehicles, not equivalent to the night that we had 4 over 6. So we don't have a direct proportion, we don't have a direct relationship here. And we'll be going over this a lot further in class. I realize that this first day that we've gone over these ideas, we didn't get a whole lot of time. So hopefully everybody's practicing and hopefully everyone's having a fairly good time with this. But keep in mind, we'll be able to go through this. I'd like to just go ahead and end at this time. Hopefully everybody's having a little bit of fun. And I look forward to seeing you in class on the 3rd of September. Or possibly the 4th if you have 6th period. Have a wonderful day.